Assalamualaikum. In today's lesson, we revisit a past upload on nuclear fission reaction and look into a revised excerpt concerning the amount of uranium fuel needed to run a 3,000 megawatt nuclear reactor. So just stick around, watch and learn. The question is, what mass in kilogram of uranium-235 has to undergo fission each day to provide 3.00 times 10 to the third power megawatts of thermal power? Assume that the fission liberates about 200 million electron volts per atom and use the equivalent of 1 day equals 86,400 seconds. Thermal power capacity of the nuclear reactor is given equal to 3.00 raised to the third power megawatts. And the average amount of energy liberated in every fission reaction of the isotope uranium-235 is known to be 200 million electron volts. And also, the length of time of operating the reactor is 1 day, which is equivalent to 86,400 seconds. And our target variable is the amount of the uranium-235 fuel that is required in a 1 day operation. All right. So in other words, we're looking for the mass in kilogram of the uranium-235 fuel. We start our computation by converting 200 million electron volts of energy to its equivalent in joules. So we do that by just multiplying the given energy, all right, converted first to electron volts. That is 200 million electron volts is 2.00 raised to the 8th power electron volts. And we multiply that by the conversion factor, where 1 electron volts is equivalent to 1.60 raised to the negative 19 joules. So when you do our math, we find the equivalent of 200 million electron volts in joules, which is 3.20 raised to the negative 11 joules. Next, we find the number of fissions. All right, the fission reactions needed in each second. So we just divide 3.00 raised to the 9th power joules per second, all right, by 3.20 times 10 to the negative 11 joules. And we will get the number of fissions needed in 1 second equal to 9.40 raised to the 19th power in three significant figures. So this is the number of fissions of the uranium-235 isotope in each second, that is. We know that the mass number of the uranium-235 isotope is 235 atomic mass unit, or U. So we need to convert this atomic mass to its equivalent in kilogram. That is, we just multiply 235 atomic mass unit, or U, by the conversion factor, where one atomic mass unit, or U, is equivalent to 1.67 raised to the negative 27 kilogram. All right, so multiplying, we get the mass of the uranium-235 isotope in kilogram equal to 3.92 raised to the negative 25 kilogram, also in three significant figures. After which, all right, we cannot find the mass in kilogram of the uranium-235 in each second. That is, M is equal to 9.40 raised to the 19th power. All right, this is the number of fissions that is required, all right, in 1 second. So multiplying that by the mass of the uranium-235 isotope in kilogram, or 3.92 raised to the negative 25 kilogram, we get the value of the mass M equal to 3.68, all right, raised to the negative 5 kilogram. All right. In 1 day of operation of a nuclear power plant, the required amount of uranium-235 fuel, all right, can now be computed. That is, we just multiply 3.68 raised to the negative 5 kilogram per second by 86,400 seconds and get the required mass of the uranium-235 fuel, all right, in 1 day operation of a nuclear power plant, all right, with a power capacity of 3,000 megawatts, and that is equal to 3.18 kilogram in three significant figures. And for comparison, a 1,000 megawatt coal-fired power plant burns 10,600 tons. That is about 10 million kilograms of coal per day. So, you see the difference? Filipino physics students, do you think it is high time for us to use nuclear power plant as a source of electricity in the Philippines? Before we end, let's emphasize the key concept applied in this problem. The thermal power output of a power plant equals the energy released per reaction multiplied by the number of reactions that take place per second. Since the energy released per nuclear fission reaction is very large, a substantial power output can be obtained from relatively few fission reactions per second. And that concludes our lesson. Till the next episode, mabuhay, mashallah. Thank you very much for your indulgence. Please don't forget to subscribe to my YouTube channel. Alhamdulillah.